think we at least do the note well. Okay. This is the note well slide that you've seen in all the other working groups. I'm hope by everybody has at least looked through these BCPs and you know about IPR disclosures that by participating, you're obligated to divulge any IPR that you're aware of. Also, take a look at all the IETF behavior BCPs as well. I'm going to go right into the status, try and do it fast. We've had 3 RFCs, all of them where Tony Lee was the primary editor. These are experimental, but they're some good work related to ISIS, area proxy, and dynamic flooding. We have one, the fast flooding, which was a collaboration by a number of people and vendors. It's almost ready. It's on the RFC editor queue. We got 2 of the primary authors are going to review it in the next week or 2, and then we should publish it. This one is on Gunther's queue to review. A fairly extensive extension to the Flex algorithm with new constraints for bandwidth and auto bandwidth determination and other things. We adopted these PICS drafts. Remember, we've been talking about doing this experiment where we do protocol conformance, Yang models, where vendors can indicate, or open source or whatever, you can indicate your compliance to various ISIS features. And this was the first shot of this by a number of authors. I encourage everybody, especially those who are familiar with ISIS, to review these. We've closed these. I'm just waiting. The first one, admin tags, we really need this for OSPF because we've got a number of drafts, at least a couple drafts that need admin tags in OSPF. Otherwise, they'll need to define their own tags. So we're really want to get this on Gunther's queue. And the multi-part TLVs. There's been a lot of discussion on that one on the list lately. Now, we're just waiting on these. Hopefully we can get these 2 drafts done, the SR model for ISIS and OSPF. These are the last working group documents that were started before the merger of LSR. So the merger of ISIS and OSPF, to form LSR. So be good to get these done as well, because then you can just do a search on -LSR- and get all the LSR documents. Possibly some on label switch routers as well, but that's beside the point. And this is another document been around for a while. Hopefully we'll get this one last called. I think that one's on my queue to do. And just the existing bunch of Yang models. And some that are ready. Authors have said at least the authors have asked for last call on the first one, the reverse affinity constraint. And did I say, was there? Oh yeah, the TTC. There hasn't been any action on this. Nobody was going to implement this one. I don't know that we need to complete it. It's expired and I don't see, I mean, we're not looking for things to do. I mean, I don't see a real need to complete that one. So we're going to let that one just drop off until such time that there's a big requirement for TTC and ISIS. And the authors of the unreachable prefix have asked for working group last call as well. We'll be looking at that hopefully after we get some of the ones that are ahead of it. And then a lot of these OSPF maintenance ones are pretty simple. We should get those done too, the last two. And then we'll talk about, yeah, these two. We'll probably do an option call for these two before the next IETF. That's it. Okay. Do you want to say anything about the stuff?
Any comments or questions?
Thank you. Hello, everyone. Okay, I can control it. Thank you. This is Li Yang coming from China Mobile, and I'm going to briefly describe the update of this draft. It is related to advertising infinity links in OSPF. This document proposes the method to advertise the infinity links in OSPF to indicate that if the IDP metric of link is advertised as the LS link infinity, it must not be considered during the related SPF computation. And it has been adopted since the IETF 119 meeting on March 2024. And this time we have updated a new version based on the discussion from the mailing list. So here I would like to introduce the updates briefly. So here I'd like to thank you all for the email discussion. First, we have updated the terminology in this draft. We have updated the document to reflect that the LS link infinity to represent the all the F value, and the max reachable link metric represents the FFFE value. And the entire document has been checked and made the corresponding changes. The second one is the flex algo related descriptions. The draft now includes the descriptions related to the flex algo, clarifying that it applies to both basic and flex algo topologies. And additionally, we have also added settings for the flex algo's metric type in the use case. The picture is the comparison about the previous version and the latest version. And the third one is the OSPF v3 related description. The newly defined LS link infinity supporting bit, it also should be applied to the OSPF v3. So the RFC 5340 has been added to the draft. And the fourth is updates to RFC 6987 and 8770. We have added a new description to reflect the updates to these two RFC. When the LS link infinity capability is supported, the max link metric must be to max reachable link metric for these two RCs. This is the whole passage for this draft. And there are also some optimization in sentence structures. For example, the previous description of the timing for recalculating the routing was not very accurate. So we have updated. Once upon detecting the change of RILC, all routers in this area must recalculate routes. And finally, we have also optimized some vocabulary and grammar, which will make the draft sentences more smooth. That's all the modification of the latest version. I think that we have completed the revisions discussed in the email. If there are any omissions, please kindly let us know. I'd like to thank you all once again. And we think that we are ready to the WG last call. Okay, that's all. Thank you.
You didn't join the queue yet.
Yeah, because I need
Yeah,
to
but
log in.
anyway,
and
go
stuff.
ahead. Just a
Hold up.
reminder,
Yes, it's
please
me.
use the on-site tool to join the queue
Yes,
if you want
yes,
to ask
me,
a question.
Will, I've been here before.
Yeah. Go ahead.
Tony P. Juniper. So there is a subtle interaction here with the way people simulate the overload on OSPF, right? Where they set all the links to metrics. And now
I'll just copy that. There's the compatibility is covered. You didn't read the draft.
no, I didn't.
It's covered
I just
in the
want to
draft.
make sure
Yeah,
there's
yeah,
not
yeah. It is
surprises.
actually
Thank
it
you.
is covered. Actually, if you remember, Kayer and Padma did another draft where they used the host bit, and that one takes care of that problem and makes it an overload just like ISIS. And yeah, and the backward compatibility. Yeah, thanks to Ketten for pointing that out when we were writing it. Sorry, Leanne, for jumping in.
Okay, thank you.
Les, are you trying to ask a question or something? I see your mic was open. Okay. Any other questions? If not, we'll go to the next presentation.
I'm not in the queue, but I just wanted to add one thing. The reason we used the metric, the infinite metric, is because that's how ISIS does it. That was one thing, to have the commonality of ISIS, even though it conflicted with the existing stub router. And the other reason is to make adoption simpler, because you do not have to access the extended prefix LSA in the base SPF. I mean, I know you can always optimize it so it wouldn't be that hard, but I think this lowers the adoption barrier just by using the metric.
Okay, I will continue with the next topic. This chapter is about excluding node in Flex algo. First, I want to introduce the background of this draft. In the network, certain nodes may need to be passed by or avoided for specific traffic during the packet forwarding. Maybe it's because some concerns related to the security, reliability, or geographical location. And For example, we draw a picture here for flex algo A. We want to avoid passing through the device R4. And for flex algo B, we want to avoid passing through device R3. To realize this, currently we can use the FAD mechanism. Now the FAD supports excluding links based on the SRGEAGO metric. To achieve the goal of the excluding node, the existing solution requires setting up the exclusion of all the links connected to that node. For example, here, all links of the R3 need to be marked as red, and all links of R4 need to be marked as green. The key point is that if a node has many links, this method becomes quite inconvenient. So the main idea of this draft is to provide a method to exclude an entire node directly rather than just a specific link. So this is the background of this draft. The main idea of this solution is as follows. First, we use some existing attributes to identify the nodes and then specify the exclusion of a certain attribute. Finally, apply this exclusion to the root calculation. And as we all know, there are already admin tags. Is just have mentioned that many features see this tag value is very useful, and so we think that this mechanism can perfectly meet this requirement. So here we want to apply the admin tag to this solution. What we need to do is just to define a new FAD to indicate the exclusion of a specific admin tag. So here we call the new FAD the exclude admin tag constraints. This is the detailed definition of the sub-TLV. For ISIS, it's a sub-TLV under the flexible algorithm definition sub-TLV. And for OSPF, it's a sub-TLV under the FAD TLV. The sub-TLV type here is to be defined. This page corresponds to the first page, explaining that after the new FAD is defined, the main process for implementing node exclusion. So I will not detail it. The next page, we have found that once this solution is implemented, it can also be applied to SRMPS scenarios for root backup calculation between the different FA. This slide provides a detailed explanation for this scenario. So I will explain this detailedly. As the picture shows, the first step, the P3 has an IP address assigned to the interface loopback 1, with one label as the primary label in flex algo 128, and the other label as the backup label in the flex algo 129. And the second step, the ASBR1 can advertise the admin tag as 1 here. And the third type, you can specify FA flex algo 128 as the primary path and the flex algo 129 as the backup path. And here we can see that the flex algo 129 can do the calculation with the newly defined FAD constraint, which can be set to exclude the node with the admin tag 1. So finally, for the root 3.3.3.3, the backup path will choose the ASBR2 and bypass the ASBR1. So this is the whole process of this scenario. And we would like to hear more opinions from the working group. That's all. Thank you.
Peter, please.
Peter Pshenak, Cisco. So if you look at the RFC specifying the basic flex algo, there is something called a participation, which is required for flex algo functionality, where every node advertises its participation in each algorithm and each data plane. So there is already an existing mechanism to exclude a node from the algo. So I don't think any of this is needed.
Thank you, Peter. Yes, it's a good question. And at first, we had the same thoughts as you. But what I want to say that the advantage of using attribute is that we can exclude nodes based on a category of attributes without having to specify each individual nodes. This will simplify the deployment when there are many nodes to exclude. I can give you an example. If we want to exclude all the nodes in the network that have not been upgraded, we can just set the tag of this node to a specific value, and then by excluding this value, it's okay. We don't need to configure on all the routers to discard the FA.
So you need to configure the router one way or the other, whether you advertise this new exclude thing or you advertise the participation. It's just a different mechanism. I don't know if I understand what is the advantage of your solution, but we don't want to have two different ways of doing things. So maybe if you can post it on the list, what is the advantage and why do you need this is needed? I'll have a look.
No problem. Maybe we can also update it to the draft. I want to mention is that it's the difference between a category of attributes or a specific router. This is the key point. Thank you, Peter.
Any other comments, questions?
Okay. Yeah, that would be good to discuss that use case where it eases the deployment. So just at the high level, I'm trying to think of the case where it would be it would work better to have the exclusion than non-participation totally, where the two. That'd be good. I think that'd be good to put that on the list.
Okay, thank you.
Yeah, Stefan Nikowski. Quick comment. I don't think there is any operational advantage. As Peter pointed, whatever you configure the admin tag of the node on the FlexAlgo participation, this is the same amount of work. So what's the point?
Yeah, I have to repeat. It's a category of some routers, not a specific router. Maybe I will send it to the list.
Leah, if you have a better use case or some more benefits, please send it to the list. And
Okay,
thank you
no
for your
problem.
presentation. We'll go to the next one.
Okay. Thank you for your question.
Tony. You want to do the timestamp first? Okay.
Here, good like this. All right, so the first one is on the, oh, thank you very much. I only have one view graph there. So that's the update on the timestamp draft, right? I've shown it last time. That's Colby and me. Autoshed open if people want to participate. So what's new? So there was a good amount of input on the mic and list. And the changes, I run it quickly through. We moved to NTP epoch, which is simpler, doesn't deal with like skipping seconds and so on, but the input from developers was significantly simpler to deal with that. And the problem with NTP epoch, because people wanted the seconds, the full 4 bytes, rather than actually working with the offset that we suggested. So that would wrap out 2036, which is not a good thing. So we basically sneaked one high bit onto the encoding, which basically bumps us to 33 bits, and that puts us into 2242. Everybody safely retired by that. All right. Bear some incredible medicinal progress. Then I want to know all about it. Anyway, then there was a good, I think from Bruno, there was a very good feedback that we are on the resolution, we're simply not good enough. So we pushed it down on the precision of the timestamp down to 4 millisec resolution. Okay, and we squeezed down the maximum slip, which is about a second, after feedback to 256 millisec forward or backward. So the slew can be basically half a second. Otherwise, you're not supposed to generate this timestamp. And the last thing was Tony's input that by all means do not use that to influence protocol behavior. So we put that in. And currently we made it basically a normative should not. We could go to must not, but it will be silly because it's basically impossible to observe. So, you know, must noting something we cannot enforce anyway is probably not much use. And I think that converged to a point where it's worth to ask for adoption, where that's something that we want to roll forward. I mean, the use case and then the one called, we put it in mostly traffic engineering currently. So they understand how good is actually the traffic engineering database dealing with. And that's a real problem we see, right, all the time. When we try to like optimize traffic engineering or signaling or whatever layouts of paths, you know, we have to know how recent is the information before we end up with a lot of crankbacks or failed stuff or reservations that don't work. So what, the adoption on the list?
Yeah. We have a couple ahead of it, but yes, we'll do it. A couple adoption.
In the adoption queue.
Yeah, I'll put it in there. I think there's
now we
only
have an
3.
adoption
I think there's
queue.
only 3. I think this is reasonable though. Did the people who commented at the last IETF read the latest version? I know you just updated it.
Right before cutoff, hey,
Yeah, recently,
there are
yeah.
important things
I don't
to
know.
do.
I don't
I'm
think.
sorry, and this was in my queue. Okay.
Well,
Yeah.
I guess we give people a little bit of time to read.
Yeah. I mean, it's not
the updates.
urgent.
I know we had a couple discussions, and I see you went through them item by item of the things to the last IETF.
So
Yeah.
we didn't see the new draft, and we didn't see the slides until this morning. So if you ask
No, you're lying. These slides you had yesterday night.
Yes.
Yeah, late.
Oh, these
late
ones,
though.
you have to keep them honest, I tell you. Yeah, the other one, and again, there are things in queues and sometimes they interrupt. Sorry, Ketan, did I forget any of your feedback? I don't think so.
No, Ketan Tarawlikar Cisco, about the use case with TE, actually, I did not follow it. If there was some reference or something more that you could explain, that would be helpful.
So basically Colby, I mean, the whole thing is driven from Colby's side, not me.
Yeah.
I think it's operationally useful anyway, because you can measure something like, maximum flood delay. So operationally, it's a cool tool, but it's basically driven, and you probably should pick up the conversation with Colby. When we're building the TED, right, from multiple sources, and this is one of them, we don't know how fresh is the info really, right? We can.
I would like to understand a little bit more if it was possible to put a reference or something.
Yeah, pick it up on the list with Colby, because like I say, I'm just here showing machinery, right?
I'll ask on the list.
He asked me to put that forward with some reasonable machinery, right? While he's really harping on the use case. And since I was thinking it's operationally pretty good tool anyway, I mean, it's worth like rolling it out, if we want to work on that. Okay. That's all there is here. So in the queue.
So 2042, the wrap is, I guess we'll be leaving that for Les to take care of.
Okay, now good. So that's it. So we can go to the other one. Am I in sequence or I sit down again?
Yeah.
Good, thank you. All right, so that's the desktop of flood stuff and what was happening there, right? After the last time where things get vivace, there's only an Italian word for it. Authors list isn't changed, right? There was a lot of discussion still with involved parties and want to deploy it, and consensus between the authors. What I'm presenting is basically the consensus that kind of gelled as the next update. Again, right, I'm not showing here some little thing that came up. This is consensus from fairly wide forum of discussions and the authors, and there was a work group input and the discussion list, and again, everything was pretty lively. All right, so the whole framework per the input of the working group that was added in 5 or 6 or something got basically shoved out, and there is a personal draft that where the whole framework is being stuck into, and that may have a certain value or not. It will depend, like, how this discussion go, what people think, and so on. And, there was recent discussions again. A good feedback was that we should not load balance per LSP ID, all right? But we should actually put a couple of subsequent fragments onto the same CDS, not the same tree, to put it simply. So basically, when we take the LSP ID, right now what we said, we basically shift down the fragment ID 4 down to, like, neutralize out the lowest 4 bits, and then we'll put 16 subsequent fragments from the same source on the same tree. After implementation testing, we basically came to the conclusion that it would be better to mask out the lowest 3 bits and only put 8 of those subsequent. And that's to do a lot with how people deploy the stuff and what are the default timer values for flooding and so on, right? Okay, so that's one change. Then, so that of course influences the hash. There is a reference implementation in Rust, couple of lines, just because I think that, we think that if people, don't run the same hash, the stuff may run into trouble, and that's why it's important to really have down the reference down to the code level, okay? AC code an excellent corner case, which even under testing we didn't see, which is that we have stale LSP fragments. The algorithm says don't flood back towards the source. So if a guy restarts, but there is stale stuff in the network, right, we will not flood back. So we added that, we don't see a difference. It would have worked anyway because of the PSNP stuff, which actually converges the stuff quite reasonably even under very, very heavy bugs that where the whole thing is not working particularly well. So there was one thing we found in testing, that we had, heavy bugs where the stuff practically wasn't working at all, and the PSNPs were still holding it up, right? You saw impact on the convergence times, definitely, but the whole thing still was at the end fully converged. So we added an operational section, and that was mostly based on large operators' input, and then also simulation of behavior on synthetic topologies, also actually running a lot of analysis on real customer networks, which of course I cannot show here. So the first output after going through this whole work was the deployment of actually a relatively few key nodes in most network topologies can bring already a lot of benefits. And I show some stats. It was uniformly fed back to us that the leaderless, possibly configuration free and minimal blast radius under any condition is preferred as operational mode. Okay, and there was a preference to include something that would show which nodes are running it and with which version of the algorithm, right? So that's right now in operational, which is optional, but it was strongly preferred. There was no significant interest in running multiple algorithms at the same time, which is actually a slightly shaded discussion. I'm just telling you what people fed me, and there's consensus in the operational section. So I show you something to, in terms of methodologies we were running. I wanted also bring some runtimes. I had a young, excited developer reformat my whole server for this purpose, overnight. So that's why I didn't come up with those numbers this time. I may show them next time. So we were running these kind of simulations on real customer topologies, but also on synthetic. There's a class of things which actually, in terms of graph properties, mirrors service provider networks pretty well. Okay, so on the left, what is shown is such a small synthetic topologies. I mean, we're running this thing at huge sizes, but then it just becomes black. You don't see anything, visually speaking. So that shows the red one is kind of one of those trees for one of the fragments originated at the very bottom on the blue node, right? And it's actually not a tree, but it is something which can have loops because ECMP is included. So nothing particular. What is however more interesting is that when you run an analysis, but of course you need a database, right? So you have to know how many fragments do people have per node, because that plays a role, right? Because if a node originates a lot of fragment, it has different, if you look at achieved improvement, you will come up with different numbers. If other nodes have a lot of fragments, you have to weight it in. So if you run the algorithm, this is run on simulation, not on the real stuff. Basically, we re-implemented the whole thing. You will see that you can generate a graph like that, which I don't even remember what we called the thing at the end, but basically the node size shows you how much improvement you will get. So the smaller the node, the more improvement. So you see that the node 9 and 12, there's a pointer somewhere, right? Thank you. So the 9 and 12 here remain relatively large. And that is an indication that even if you try to do flood reduction there, you won't get much, because they are in something which is in graph theory called an articulation. So basically, if you cut here, you get two networks, right? So depending where you put in topology, you will get different, amount of reduction. Now, that whole thing boils down that you can basically look at the distribution, right? How many nodes do I have to put it on and where to get how much gain? And on average topologies, and that's kind of a conglomeration of a lot of histograms, is that if you deploy it just on 1/3 of the nodes in the network, on the correct nodes, you already got about 90% reduction in flooding volume, all right? The next, so they will reduce, those 1/3 of the nodes will reduce 90% of what they would be normally flooding. I don't know whether it's clear. So there's 1/3 of the nodes in the network, you switch it on, and the flooding volume drops 90%, okay? Well, those are the histograms generated from real customer huge topologies.
So you're saying you only configured it on 1/3 of the nodes?
Yeah, you just run in 1/3 of the nodes. Again, I'm obfuscating here a lot of data I'm not supposed to talk about, all right, in any detail. But that's what we're seeing, right? Another 1/3 of the nodes, there's like 70–80% volume reduction. And then, no, it falls off. There's a small fat tails. Actually, it looks like a fat tail. So at the very end, there is what, about 10% of node, you don't get anything. There are, however, networks where the topology is extremely well built. So if you just deploy it on a very few nodes, you get most of the reduction. But, those people built it in a way where, this thing kicks in very well.
So that's kind of intuitive because those nodes are relying on the fact that the other nodes are flooding, so they don't need,
Well,
okay.
The conoscenti will start to read between the lines. This is as much as we can actually disclose, okay? And I didn't bring any CPU numbers because we're still pulling them, and in the middle of the whole work, the server just got reinstalled to the newest version of Ubuntu, which actually crashes with Docker. Okay, so now if we start to talk, should we do something about the leaderless stuff, right? So should we have a framework for some kind of a leaderless operation, possibly, mixed mode with a leader, multiple leaderless algorithms, whatever. So if we just have this topo on the network, nothing is strictly necessary. You can just run it, right? And like I said, there's a strong preference that we should advertise the version of the stuff that is running. If we have multiple algorithms, yes, of course, some signaling would be necessary, right? So for basically the running algorithm, if you have an indication of the running algorithm on the network, then you can basically arbitrarily mix leader-based and leaderless and multiple algorithms, like if you ever need that, right? The only real practical consideration that we've seen is what if you have a very serious improvement or a bug and you have to migrate, and it has to be node by node without any blast radius, okay? So this is the picture from this thing that became a private draft. So you could basically have, islands of things, components which understand we are configured or running the same algorithm. And the only rule is that if they see on the other side something else, they're fully flat and the whole thing will work. So it's actually not that complicated, right? In terms of why it would work, graph theory wise. Now, so from all that I was seeing, and then we kind of have a discussion, the consensus was kind of veering towards the question, should we even work on some kind of a leaderless signaling for distributed flood reduction? With no configuration ideally and minimal blast radius and no flag data and so on. So that's something that I suggest to call a consensus on. All right, and we know, should we even go in this direction? Should we completely abandon it, and the workgroup would not pay attention? And I think that's the rest. The rest is like technicality, it's not important. So if you want to get a consensus call, we get some direction and, we know where to go from here. Without that, it's, we can argue, necessary, not necessary, should be done, shouldn't be done. So that's kind of the meat of the whole presentation. The rest is kind of like follow-up stuff. Where do we put it and how to know technicalities?
Well, we'd have to do that on the list. We'll let everybody talk, and then we'll see, first of all, how many people understand the discussion and get a sense of the room. And then, but first we'll I know that I see Les is queued and possibly others want to say something.
Les, please go ahead.
Yeah, so, I think my position on this has been made pretty clear on the list. And Tony, you and I talked about this in person last time. There's two things here. One is any discussion about how you enable the algorithm. Whether you do it without any controls, whether you do it leaderless, whether you do it with a leader, is independent of this algorithm. Do we agree on that?
So we were actually looking whether the algorithm would need changes if it runs with the leader, and it looks like would. But I didn't look.
No, but that's not the question. That's not the question I asked. Suppose somebody comes up with some other algorithm. Okay.
Where are we going with this? Okay.
Is there any reason why the control mechanism for enabling it would be any different?
And that's what I answered right now. Okay, but Shraddha would have to chime in because she was looking at the stuff in more detail. It looks like the algorithm will have changes if you run it with a leader or leaderless. But that's as much as I can tell you. So I can't answer the question affirmatively, yes or no. What I heard is yes, the algorithm has a change, needs technical change.
Okay, I don't see that. If there's actually something there, then somebody's going to have to indicate what that is. But this is the reason that we want any discussion of how any algorithm is enabled to be independent of description of a particular algorithm. So I have no issue.
Did he drop?
No, I can still see him. Les, are you speaking? If so, we cannot hear you. We lost your voice. Okay, so Shraddha.
Waiting for a new leader.
That was so politically incorrect.
Les? Okay. Shraddha, maybe you want to say something?
No?
Hello, Les?
Can you hear me now?
Yes, we can hear you now.
Okay, sorry. I've had audio problems on my laptop. I had to reboot once already, so I don't know what the story is.
Houston, you read loud and clear. So.
Thank you. So I was just saying that this is why we want any discussion of how an algorithm is enabled, whether it's leaderless, whether it's with a leader, is logically separate from any particular algorithm itself. And I think the best way for this to go forward is for those two things to be separated.
Okay.
Shraddha, if you want to answer the question, you can just start.
Yeah, sure. So this particular algorithm has one step which
Can
is
you're very low, Shraddha.
Yeah,
can you get closer to the mic, please?
Yeah.
No, she's also remote, Les.
Okay.
Hello, can you hear me now?
Unreadable.
No, your voice is very low. Maybe you try to speak closer to your mic.
Hello, can you hear me now?
Barely.
It's a little better.
Hello, can you hear me now?
Can you be a little bit louder, maybe?
Hello?
Yeah, can you try say something, see whether we can hear you?
Yeah, is it better?
Shraddha, are you still there?
Yeah, this can go probably. I will fix my headset.
All right. I'll let other people go ahead. So.
I think I'm in the queue too. I got one. Am I?
Peter.
Peter. Oh, Peter's next. Okay.
What I wanted to say is, Peter from Cisco, is
Hello,
that
can you
I
hear me
can't
now?
imagine.
Yeah.
Hello, can you hear me now?
Yes,
Yeah,
a
go
bit
ahead.
better. Go ahead.
Yeah, so I just wanted to answer Les's question about algorithm being completely independent from the framework in which it is running. For example, this algorithm has a dependency on the framework on which it is running in step 4C. I think you can go back and look at the document. So it has a dependency because if the neighbor is running a different algorithm, then the steps in that algorithm has to account for the fact that neighbor is running a different algorithm. So that is the dependency. So I do think that we cannot assume that every algorithm that one comes up with will be completely independent from what framework it is running in. So
Yeah, it will go a little bit into the weeds, but actually there is a very subtle difference because between something that is configured to run something is actually running this algorithm, right? And that can actually influence the algorithm.
When it's my turn, I'll clear it all up.
The boss will clear it all up, but.
All right, so Peter, Chenak, Cisco. So I think having any dependency between how the algorithm works and the signaling of what algorithm is used is a bad idea. I understand why you have to do it, because you may have multiple algorithms running at the same time. So the other solution that we have guarantees that there is only always one, so we don't need that dependency.
Right, and so now I'm chiming in, but that leads again to the discussion: do you want a flag day or not, and do you want a blast radius? Because if you upgrade the algorithm and you have a bug, then you have by default you have two running, okay? Unless you basically say I configured a second and then I flag everything to the newer version on all the nodes, which shakes the whole network, and that's fine. That may be operationally completely fine, but I basically have shown what is the consensus of the discussions. Right.
So
I'm not saying it won't work. It just has different properties in terms of deployment.
So we can argue this, flag day, no flag day. It's a longer discussion. All I wanted to say is that I don't believe having that dependency is correct. And you solve the problem by having multiple algorithms to be supported. Not that you want to, but that's your solution needs that, right? So I just want to point out that the other solution that is there doesn't have that problem and that dependency.
Well, so I mean, the multiple algorithms can be hacked out the algorithm, and then maybe actually it runs leaderless and without any changes, right?
Well,
that is just like I said, the feedback was that nobody's interested in running multiple algorithms at the same time.
I agree.
Except this fine point where I said the migration is a discussion, right, on bugs or improvement. Improvement, nobody believes, but the bugs, I will not sign my life on, the first thing we ship will be in concrete and never break. Sorry.
Right.
Yeah,
So the migration, whether you do it, so all we want is basically single algorithm. We all agree that we don't need multiple. I guess we agree on that, right?
Don't know. Like I said, I mean, I'm asking, so, I think the question in the room is, do we even want to work on something leaderless or not? If not, fine, work group not preoccupied. If we want to work on leaderless, then this leads to this further question. Yes. Do we even bother about multiple algorithms?
Well, but that's how you migrate with your solution. You enable the new one on some of the nodes, and then you have multiple running at the network.
It's the solution space. And what the workgroup consensus is, with the input from all the customers, how important it is for them, for the complexity added, is something that should fall out.
I don't argue that point. All I'm saying is that the other solution doesn't have this problem, which doesn't have the problem of dependency of the signaling on the algorithm. That's all I wanted to say.
So if you run just this algorithm, right, leaderless, you don't literally need anything.
Right, but Tony, we know we can't predict what the future comes.
Well, so now you're telling me you will have multiple algorithms or you migrate. So that's contradictory to me.
No,
but I think we're going to the weeds.
Yeah, I think what it says, the version of the same algorithm, just with a version that has some corner case where it's incompatible. So you need to know the different, you need to.
Right.
Yeah, which was another one. Here, okay. I'm up.
Okay, your turn. Hopefully.
AC
you can
Linus.
read out.
Yeah. Speaking as working group member. For the distributed case, minimally, all you need to know is whether your neighbor is running the same algorithm as you. However, no, wait, I'm getting there. Okay, give me time. Minimally, that's all you need to know. However, knowing whether or not his neighbors are, you can optimize a lot better. So it's a lot better to know. So you can't put it in the LOs. You have to put it in the LSPs. I mean, you don't have to, but it helps a lot better. Now the difference between the two is in the leader, the current one we have, you have to see what one the leader selected, and then go and see, oh, do these guys support this? Then you have to assume that they are running the algorithm, as opposed to them advertising that they are actually running the algorithm. So that's the difference. So you can do it either way, but the leader list is simpler and it's more sure. And it does help to know whether or not, because in your algorithm, you can take advantage of the fact that people who aren't running the same version or same algorithm are going to flood normally, and then you take advantage of that, and that may optimize so some of the other people don't have to. And that's the fundamental difference between the two. You agree now? You just had to let me finish.
No, we're deep into the weeds, but yes, it is actually a consideration. Yes.
Yeah.
Peter from Cisco. No, in the current solution, you don't need to understand what the others are supporting. It's not required. Right? No, you don't. You basically compute a topology, and if you hit the node which doesn't support it, it does more flooding. But you don't need to know of any other nodes what they do.
Yeah, I think we should take it to list.
Yeah.
You want to say something, Tony?
Tony, yeah.
You can go ahead. You haven't spoken yet.
I disagree with Peter. If you look at the graph, it's very important. In case where there are multiple connections, you have to know what the other half of the graph is doing.
Yes.
If somebody over there is misbehaving and doing something completely different because they're running a different algorithm, you have no idea what's actually happening. And you don't know whether you are become an articulation point between the two graphs or not. You have to understand globally what's going on. And running multiple algorithms without any semantic knowledge of what's going on is death.
Just a quick one, Peter from Cisco. Yeah, I agree, but the premise of the whole leader solution is that everybody agrees on the particular algorithm. There can't be any mix. So all you can have in a network is one algorithm or the full flooding. And that works without knowing whether the nodes are supporting it or not.
That's fine, except that different versions are semantically equivalent to different algorithms.
Okay.
Gunther, you are the next. Yeah.
Gunther van der Velde speaking as a participant here. So actually, I like the leaderless, mechanism. I find it elegant. Even I am capable of understanding it. So, which means, it's not that complex. I also believe, it is something I see, as a vendor, implementing at some point in time. And because I do see interest from, I can see the interest from my customers in this. They can do this like, without a flag day, do it like box by box. No complexity of leader election or leader assignment and those kind of things. So I like the leaderless approach.
Shraddha, you're next.
Yeah, so I just wanted to remind the working group that this algorithm is derived from the MANET, the algorithm that runs it's already defined, deployed, which runs in the MANETs and in a leaderless mode, right? So it has the experience of running this algorithm in a leaderless mode for the longest time. That was just my point.
Just clarifying, she's referring to the OSPF Monet work that was done during the, like circa 2005, 2007.
20 years.
Yeah, in this working group, or in the OSPF working group.
Okay, Les, you are the next. We can now hear you.
Houston to Eagle, you're rebooting again?
No, Trump turned off the internet to California.
Can you hear me now? I guess not.
Yes, we can hear
Oh,
you. No,
okay.
go. Yeah.
Okay. All I want to say is that the claims that with a leader-based enablement, that you've got a terrible blast radius if you want to migrate from one algorithm to another is not correct. We can go through the details. I'm sure we don't want to take the time right now, but that statement is not correct.
You have a flag day which affects your whole network. But again, we can take, that's like technicalities. Because the real question stands in the room is, should we even work on that or not? Yeah. So we put cycles into something that matters, or we decide it doesn't matter.
Okay, yeah, I mean, this is more involved. We obviously got to take this to the list. How many people in the room understand the different alternatives here? We got from the existing and the new one. Okay, looks like at least a third. So that's good. Yeah, we'll take it to the list.
So in this case, no adoption call. Okay, also no consensus call. Ah, yeah,
But
interesting.
I think one thing that would make things simpler, are you going to have a separate draft?
On what?
Leaderless operation. I don't know.
Because if we don't want to work on it, why put cycles in it?
Oh, okay, that's true. Yeah,
That's
okay.
what I'm asking. I mean,
Okay.
Sorry, I have a long queue, and this is not a very high priority. Okay.
So if the consensus call is yes, are you going to put it in a separate draft or combine together?
No, then we start to work on the draft explaining how a leaderless mode works. Again, depending on, I mean, it depends what the work group wants, right? If the work group wants consider multiple algorithm, it's follow-up decision. If the working group wants to consider actually a reconcile framework that supports both, then it's, yet a different decision. And then it really becomes a question where to put it. You can base the stuff with the leader. It's actually not that hard to include both. We can have a separate document. If people decide, well, there's one algorithm good enough, then you can drag another document. I don't know what that serves, but fine. Okay, but right now, there is nothing really in the draft. It basically says indicate the version you shoot for operational purposes. That's the feedback we got. So there is the whole framework that could run a mix of multiple and leader and leaderless, whatever in the most extreme case, is in the private draft. So I can ask for the adoption for the private draft, but it's a waste of time if the consensus call is there is no leaderless mode. Then
yeah, I see your point. We can have a discussion here, but we will have to take the consensus call to the list. Yeah.
Rules change again. Good.
Yeah. Any other comments, questions? Okay. Thank you, Tony. Peter.
All right, so it's Peter from Cisco. Let me present the flex of data plane that we work together with Les and Zheng. So the use case. So currently, the way the flex algo is defined, that you need each router to signal the participation. The participation is signaled per data plane. We already support multiple data planes, which is segment routing, SRv6, IP flex algo. Now, there are some requirements coming from other groups, and I will mention later which ones, where people want to use the Flex algo without the presence of any of these existing data planes. They just want to run it on a plain IP network. We have IP Flex algo, which can do that, but the problem with that is that you need to advertise your prefixes as an algo prefixes, and that would mean you lose the reachability of these prefixes in the algo zero topology. So that is not really an option if you are in an existing network. So one of the applications for this would be PIM, where they want to use FlexAlgo to compute the low latency pass for multicast or low latency tree. And they want to do this on a regular IP network without any existing FlexAlgo supporting data planes. So what do we define? Basically, we define a new data plane for FlexAlgo, which is not really a data plane from the standpoint of the forwarding. So we don't expect the result of this to be put into the forwarding directly. We leave this topology or whatever is the outcome of this to be used by the applications that are actually building their own data plane. So if PIM is going to use this data, the PIM will signal, and the forwarding for PIM is independent of the calculation of this. So, well, we need to have a way to signal this. So this is the TLV that we use similarly for SR or IP Flex algo participation. So it's just another type where we say, oh, I support this so data plane, you can use me and calculate the pass via me. All right, that's a very simple thing. If you have any comments, I'm more than happy to answer. Just one thing, we have updated significantly the PIM multitopo / Flex algo draft to reflect this, because originally as it was written, it was not functional really. So now it has been updated.
I just wanted to point out this PIM draft's going to be presented tomorrow at the 1 o'clock PIM session. Oh, speak of the devil.
Sunny, on ZTE, after discussion, we think that this method fits the multicast requirements very well. So we think it does make sense. Yeah, we agree on this method. Yeah.
There's someone else.
Ajun.
Yeah, I have read the document before, but don't get the exact use case for the for this draft. So I think would you like to provide the more exact example to explain what why you propose a new TLV or new new software algorithm? Why the current algorithm cannot solve it? Okay.
So I would start with read the draft that on the PIM site, the use case is described there, and why we can't use the existing mechanism, because we are not, or the requirement is that any of the existing data planes that FlexAlgo supports is not being used in their use case. So that's why we need to come up with something different so we can address that use case.
So as I understand, it described as a meta algorithm. It doesn't depend on any existing algorithm.
Yes.
Okay, maybe. Okay.
Multicast reverse pass forward verification is one of them, right?
Yeah. Okay.
Okay. Thank you.
Thank you.
Yeah, at least from our perspective, it seems pretty straightforward. At least for Flex algorithm.
Hello, Lan Cheng from Zhongguancun Lab. I'm going to introduce this solution. This is a protocol-independent intradomain self solution, and we believe it can be implemented by using existing IGP. So we request a slot here, but this is a protocol-independent design. So for Spark-based subnet, the deployment scope is focused on serve on routers facing an internal host network or an external network or external AS. We believe there are 4 advantages. The first is these routers are closer to the source or host, and thus will be more effective in blocking source both data packets. The second advantage is compared to serve on inner routers of an intradomain network, serve on these routers should be more feasible and easier to implement because it wouldn't be affected by FRR or other complex forwarding policies inside the intradomain network. Then it can provide incremental benefits when these routers incrementally deploy Spark-based subnets. And finally, if we already have serve on these routers, on these interfaces, serve on inner routers will not be needed. So we believe this is a better use case for intradomain serve. And it aims to generate prefix allow list or prefix block list on specific router interfaces in an automatic way. The allow list defaults to blocking any, but will allow source prefixes in the allow list, and the block list defaults to allowing any, but blocks source prefixes in the block list. And there are 2 goals. The first is serve on interfaces facing an internal host network. It will block source spoofed data packets from that network that use source IP addresses of other internal host networks or other external networks or external ASs. It can use an allow list here. The second goal is serve on interfaces facing an external network or AS. It can use a block list here to block those source spoofed data packets which use source IP addresses of internal prefixes. And there are 3 main steps to generate such allow list or block list. The first is Spark message generation. A Spark message can contain 2 main types of information. The first is source prefix, that is the source addresses that can only be used by data packets from an internal host network. It can be learned from the router's local routes to that host network. But in some asymmetric routing scenario, the locally known source prefixes may be incomplete. So routers facing the same host network should exchange their locally known source prefixes. In this way, a key sub-specific information, the host network identifier, is needed. It is used to identify which host network owns that source prefix. After that, the router will provide its Spark messages to other routers. Although this document introduces protocol-independent designs, but we believe how to sub-specific information and how to transmit such messages are not in the scope. After that, after receiving Spark messages from other routers, each router can generate allow list or block list. For allow list, the router facing an internal host network can generate an allow list by including all source prefixes in Spark messages with the HNI value of its host network. And for block list, subnet routers facing an external network or an external AS can generate this block list by including all source prefixes in Spark messages. The most recommended use case is at the edge. And here is an example in the most recommended use case. And we show an asymmetric routing between routers A, route B, and the host network 1. In this case, route A and route B can generate their Spark messages containing the locally known source prefix P1 or P2. And after that, they can process the allow list containing both prefixes because both of them have the same HNI value of that host network. And for the router D facing an external network, it can generate a block list containing prefix P1, P2, and P3. And now we can compare this solution with existing intra-domicile solution. If we use the LSR-based ingress filtering, it requires manual updates in a dynamic network, so it will introduce high operational overhead. And if we use the UIPF solution, it might have improper blocks in asymmetric routing scenarios or has too many improper admits. And SPAR-based subnet can fill this gap. It can automatically generate sub-roles and it can meet the two goals of intra-domicile with no improper block. We also provide an alternative use case on area border routers in inter-area cases. Okay, in the next step, we'd like to design how to implement this solution by using OSPF or ISIS. Based on our early discussion with several members of LSR and subnet, the solution should be designed towards effective and efficient. It must avoid affecting the normal OSPF or ISIS, and we believe it's possible to use the existing sub-TLV to signal such HNI value. Okay, thanks. Any questions?
Okay, Xue Yan.
Okay, thank you, Lan Chen, for the presentation. Can you back to, yeah, this one. Okay, I noticed in this figure, you use host network. Actually, in the intra-domain architecture draft, for the scenario, the filtering interface, it listed two types. One is a host-facing interface, and the other is customer network-facing network, right? But
Yes.
in this figure, you only use host network. From my perspective, host network is a list of the devices. But for customer network, it may be, include many hosts or routers. It can be considered networks. So for this figure, I think it's not very accurate to cover the scenarios in the architect draft. Do you think so?
The host network is a layer 2 network.
Only layer 2.
Yeah, it's layer 2. So this is
For
the
layer
physical
3,
topology.
for example, customer network.
Yes, we have discussed this stuff with several people recently, and several people have spoken that customer network and the AS is connected while BGP, so it might not be solved by using IGP. So in this solution, I only display the host network here.
Okay, so this method is only for the IGP, right?
Yeah, yes, that's why we present this solution in LSR.
Okay, okay. Thank you for clarification.
Okay.
Hi, thank you for the proposal. I'm a little confused. Maybe I'm not catching something. In the case of a non-transit network, why do we need any more information? Don't we already have all the prefixes you're describing in the IGP?
Yes. The scenario here is there is an asymmetric routing because of some configurations. So the router A in this case may not learn the full source prefixes of the facing network. So in this case, router A and router B should exchange some information, self-specific information to
Router A and B already have the same link state database, correct?
Yeah.
So they have full prefixes for the entire domain.
Yeah, but there might be a configuration to violate these line prefixes.
I think you can correct me if I'm wrong. I think the assumption is you might want to not do this for every prefix in the IGP domain, the interdomain for all. And so you're going to explicitly say which prefixes. Now, that can be debated. Why would you not want to do it for every prefix, but do the SAV, populate the SAV table, SAVnet table. Is that right?
Yeah,
Shouldn't we be trying to solve the simple common case first?
So the interface A and interface 2, interface 1 and interface 2 are those IGP interfaces.
Yes, here, sure.
And they could be used for intra-domain transit,
but
right?
Do they advertise the same prefix?
So in this case, they might not advise the same prefix, or they advise the same prefix, but their FIB, the next hop interface in the FIB are not symmetric in these two interfaces. That is what I mean, the asymmetric routing.
Okay, I'm very confused. Never mind.
Oh, maybe you can say, what's the prefix you are advertising in ICP from router A?
Router A, in this case, router A would advertise P1 and router B would advertise P2 in IGP. This is an example of asymmetrical routing here.
So, but to my understanding, Peter.
Peter from Cisco. So Tony, I'm with you. For me, if router A and B are attached to an L2 network, they should have the same subnet. But and we've had some discussion with the subnet folks. What they somehow believe is that they can configure router A and B to only advertise a part of the subnet. For me, that's a broken thing. We should not even think about it. But yeah, that was my comment. Thank you.
Thank you.
Not only that it's broken, but if A and B are connected on host network 1, then if strange things start happening above them, those interfaces could end up as transit for the entire AS.
You are right.
Okay, so why not just take all the prefixes in the AS and let them in the allow list? And I don't see that we need any new advertisements whatsoever to do that.
It's a possible solution.
Okay, your turn.
Well, okay. The chairs had a discussion of this, of LSR, and we don't know how much discussion we missed in SABnet. So we decided this is not populating these tables is for that working group. And they can, but so that discussion, so they should, but the requirement should be clear. So I think we need to have a clear requirement as to why you need them. Yeah, why SABnet needs these, but we're not going to discuss in detail. We're not going to take on that problem of determining, but we need the use case better defined, I think.
Okay, thanks.
To be more specific, you're suggesting adding more things to the IGP, and it looked to me like you were duplicating all of our prefix advertisements, which seems like some overhead.
I think you're using the existing prefix advertisements and you're just tagging them, right?
Yes, we just use existing prefix.
Okay, then I don't understand why you need the tag at all.
Because this, from our point of view, a very not normal configuration.
Yeah. This might be a corner case, but if that exists, UIPF will have problems. So we try to design a more robust self-solution here to avoid blocking legitimate traffic.
Okay, but we don't want to be putting externals into our IGP if we can help it anyway. So what are we advocating?
Thanks. We will think about it.
Adrian, you are next.
Yeah, Adrian from Total. To answer to AC's question, currently in the CellNet working group, we just finished the intra-domain and inter-domain architecture working group call, adoption call, and now we will begin the discussion for the solution for the intra-domain. So we are also welcome the expert within the LSR to participate in the discussion. I think the solution draft should be located mainly in the cell network. For after the solution proposal was adopted, I think the specific protocol extension can be discussed in the LSR working group. Okay.
Peter, you want to say something?
It's Peter from Cisco. Just a quick one. As we discussed yesterday, and I concur with Tony, we should not allow any external networks to be added to the IGP for a purpose of the subnet. Because as we discussed, these customer networks, they are never carried by the IGP of the provider. They are being advertised by BGP. So if you want to exchange some specific information about those for your purpose, then either you go to BGP or come up with something else. But I don't see how the provider would ever allow the customer networks to be part of their IGP. They would just not do it.
Yes, thanks.
Thank you for the presentation. We'll go to the next one. You can just send me a new slide or whatever you can use. We have enough time.
We don't have time.
Hold on. Which one is the new one?
I just approved it a little bit ago.
Is this the new one? 哪一页能看出来？这已经是新的，对，这是新的。
Oh, sorry that I didn't.
Oh, hi, I'm Shengnan
Okay.
Yue from China Mobile. My first draft is the signaling SoundNet capability using IGP. We have two observations. Problem one, if all prefixes are involved in SoundNet, it will lead to a large number of self-interest and possible filtering. To deal with this, we extend the IGP with SoundNet source prefix flag to identify whether the prefix will be considered as a SoundNet prefix. And with this, we can reduce the cell table scale and provide a more flexible control. And problem two, there may be devices that support the SoundNet, and the devices that cannot support the SoundNet in the network at the same time. So the network capability of the so the SoundNet capability of the devices need to be identified. So we extend IGP with the SoundNet subnet capability TLV of nodes and subnet capability in BGPLS. So the possible cases may be the controller-based subnet. And subnet solutions are out of scope in this draft. Next slide, please.
Did you set auto play in your slides? Yeah, anyway, go ahead. Yeah. Just keep
It's go by itself?
Yeah.
Oh, man.
You could always set auto play or something.
I didn't say that.
Maybe
It's a PDF. The extension of the subnet.
It's just keep. Hold on. Let me close on the shot.
Is there a...
Let's try again. See, it plays itself. No, go ahead. Yeah.
The extension of subnet source prefix flag. There is a new bit in the prefix attribute flags for is and a new bit in the prefix attribute flags for OSPF is added in the figure. As flag one site, it indicates that the prefix is used for source address validation in the data plan. So the extension of subnet capability will exist otherwise exist router capability TLV OSPF or OSPF will 3 advertise OSPF router information capabilities TLV, so they can carry the subnet capability sub TLV. There also S flag when set the router supports the network functionality. Next slide. The extension of subnet capability in BGP-LS. So there is a new subnet capability TLV in BGP-LS LRI, and attribute TLV is as follows. As flag when set the router supports the subnet functionality. So that's all for this draft.
So the assumption is, I'm in the queue. So the assumption is that all the prefixes are allowed if they satisfy the existing RPF check, and this is for prefixes for which you need to do additional exception case processing, correct?
Yeah. We don't want all the prefix added to the maybe the table.
But for the ones you don't provide, you're going to just use the existing source route RPF filtering, right? You're going to allow them if they come in on the interface for the reverse path, right? And for these are the ones you're going to, or if you don't have this prefix on, everything's going to be blocked. Is that which one?
If we don't have this flag, it will not add to the table, so it won't be.
It won't be allowed.
Will be filtered.
Filtered. Okay. So it'll be blocked. Anything that's not in, that doesn't have any source that doesn't source route that doesn't have this flag will be blocked. Okay.
It will indicate the filtering area, the range area.
Is there a second?
Next slide, please. So then I will introduce source address validation in intra-domain network. Next slide, please. So this, as in the picture, there are 3 types of devices. Access device such as router A, B, and C. The intermediate device and the border device such as E and F. And there are also 4 types of interfaces. Interface 1 and 2 are the access interface. Interface 3 is the intermediate interface, and the interface 4 is the exist interface on the border, AS border. And there are 2 types of SAR roles, the allow list and the block list. And there are also 2 scenarios according to whether the source prefix is advertised by IGP protocol or the BGP protocol. Next slide. So for SAR on access interface, it is recommended to use allow list rule. In the symmetric routing, we just generate a SARnet rule directly. And in the asymmetric routing, for example, the picture below, the customer network, if the customer network only advertise the right different prefix to router A and B. If we use the strict URPF in this situation, it will cause the false filtering. So in our method, we advertise the prefixes with the low priority, and then the prefix will generate the SAR rows on both the right SAR rows on both router A and the router B's interface. We can do this by let the customer network advertising the prefix or just configure it in the router A and B. Next slide, please. For SAR on intermediate interface, it is recommended to use allow list. In our method, we use the information in LSDB of IGP protocol to calculate the connectivity and determine the interface. For example, for the SAR calculation on router A in scenario 1, the left picture. So it's from its interface A1, we can get node B and the node C and the prefix P1. Then we can combine the P1 and the interface A1 to generate a SAR entry. And also the verification on the intermediate interface is optional. Next slide, please. For SAR on exist interface, it is recommended to use block list rule for filtering on exist interface. So on the border router, first we calculate the prefix and the ingress interface using the method before for mediate interface, then convert it accordingly into the block list of the existing interface. And in this case, we can use the flag I introduced in the first draft, or the if it's the BGP scenario, we can use the BGP community to indicate the prefix that we're considered. Next slide, please. We just say that there are if the source prefix are advertised by BGP, so in the immediate interface we can generate the SAR rule based on the IGP SAR rules, and we can get the interface according to the BGP neighbor and the next hop to find the interface and the prefix. Next slide. Next slide, please. So, running code, we conduct experiment and test data. In this year, the hardware device and the software implemented has passed the test of intra-domain subnet hosted by China Mobile in this year. We use the H3C and RayJet devices, and both the single-homed and multi-homed subnet scenarios have passed the test. Next slide. Here is the topology. We use the access, intermediate, and aggregation devices. Next slide. We advertise 20,000 and 40,000 route number, and we find there is little impact of access interface, allow list, and intermediate interface, allow list. Next slide. And the exist interface block list on forwarding latency. Next slide. So there is also little impact of aggregation side down link allow list. That is also the intermediate interface allow list on convergency. And next slide. So there is the CPU usage and the memory. There is no big increase. Next slide. So summary, the verification at the intermediate phase can be optional, and also the verification and the intermediate layer may be lenient in the context of hierarchical and complex network environment faced by carrier. The connectivity calculation does not correctly discard legitimate traffic and is cost effective and easy to deploy. So next slide. Sorry. Any comments are welcome. Thank you.
Okay, first comment.
Yeah, first comment. AC Lindum, speaking as working group chair, I don't think we would adopt the second draft. That's a Savnet draft. Yeah, and I encourage people to participate in this. Like, for instance, if somebody wanted to ask why you'd ever do it on an interdomain router, because the number of transit, the size of the table would seem to be, especially in a provider network, seem to be huge. Anyway, that's what I'm saying. So it would be the document where you mark the prefixes. That's the document you'd ask for here. And also Ajin said that you were very early in the solution, so maybe it'd be better to get further along on accepting the solutions in Savnet before asking for adoption here.
I think from ICP point of view, we will need to wait for the architecture at least for the intra-domain case in Subnet to be stable before we even considering any work in LSR working group.
Cisco. So yeah, I agree with you. One question or one comment. I mean, you've been describing doing the checking on the routers internal to the domain. There are known issues with it in terms of fast reroute or RSVP or any type of a TE where the traffic may not come over the interface that you expect. So I would not try to come up with any extension to the protocol before you can solve that problem.
So our solution in the intermediate interface is lenient. So as long as the its reachability it can connect through the reachability. It can go through the that interface. It will reduce the false filtering.
Peter, to my understanding, they are not doing a very strict RPF checking. So in the internal routers, their proposal is to do a BFS calculation. So from that router, any prefix that you can reach, they include that interface.
And
So
what's
it's a sort of like a very loose RPF.
What's the point then?
Yeah, I agree.
Thank you.
So you have to explain, since you include pretty much all interfaces, what's the benefit of doing this self-checking?
I think if there is not all the devices employ the SoundNet, for example, if the if the prefix one if a customer for
So I'm also the cause of this draft.
Yeah, please go ahead.
I think the partially deployment of the solution at that moment it's useful, and it's very hard for operators who can upgrade all the routers to support all the things at the same time. So partially deployment is a basic requirements. Thank you.
So at least this presentation and the previous one, we can see the problem scope for the intra-domain case are very different to ICP. So again, to us, we'll need wait for the intra-domain architecture to be stable, have a clear problem statement and the scope. Then we can work on any ICP solution.
Okay, thank you.
Thank you for your presentation. And with that, we are done with all our presentations today. We have open mic if you want to talk about any LSR proposals, that's the time. If not, we'll see you in Bangkok. Yeah.
Yeah, that really, that stuff.
The whole thing. Yeah, I think this is previously we talked about there is a draft about the restarting solution. There are two drafts now. One is from I think the course from Juniper. The other is from China Mobile and H3C. And I think previously, I think last meeting, we have some decision that we would like to merge the two drafts.
Which draft are you talking
The two
about?
that were, you're a co-author on both, right?
Yeah.
Yeah.
Yeah. So, but I think the causes seems did not. We did not get the agreement on that.
Okay.
Because you can find the both drafts now have been updated. Yeah. So I think one is OSPF Genesis surprise, and the other is Juniper's draft. Yeah. So what should we do next step?
Those are still personal draft, right?
Yeah. Individual draft at this moment.
Yeah, individual draft, you guys can just talk offline and then do whatever you think
Okay.
appropriate, best
Okay.
for you, right?
Just remember, less is more.
Okay. Okay. Thank you.
Yes. Actually, I like the first one better because it doesn't do things on the inside. We talked about that at lunch on Monday.
The one in internal IZP routers, that will break so many things.